Hello and welcome back to the second part of our presentation on basic power electronics, Unit 1, Thyristor family devices. Myself, Sanjeev Kumar Singh, lecturer in Electronics and Telecommunication Department at Praveen Patil College of Diploma Engineering and Technology, Bhandar East, Thane. In this presentation, we'll mainly see the two devices of the Thyristor family device, that is LASCR and SCS. The course outcome is, of course, is to identify the power electronic devices in circuits, and unit outcomes remains as we already covered in the first part. So here is a diagram representation of the symbols and the different devices with their voltage ratings and operating frequency, upper operating frequencies of the Thyristor family device. So Thyristor family devices, we can divide it as the power diodes, firstly, which can be operated with 500 volts and 500 ampere of currents at frequency of 1 kilohertz. Then secondly, the thyristors group, in which SCR, LSCR, reverse conducting thyristor or asymmetrical SCR, GTO, gate turn off thyristor, SITH, MCT, TRIAX undercome. Then thirdly, we have the transistors with the BJT, MOSFET and SIT, IGBT. So the thyristor we can see here is rated as 7000 volt and 500 ampere of 5000 ampere of current with the operating frequency 1 kilohertz. LASCR 6000 volt with 3000 ampere current and 1 kilohertz of frequency. Reverse conducting or asymmetrical SCR 2500 volts and 400 ampere of current with operating frequency increased to 2 kilohertz. Gate turn off thyristor can be operated at 2 kilohertz with a voltage rating of 5000 volt and 3000 ampere of current rating. Similarly, SITH can be 25,000 volt rated and 500 ampere of current with 100 kilohertz of operating frequency. MCT similarly, it can be of 1200 volts 40 ampere with 20 kilohertz of operating frequency. TRIAC with 1200 volt 1000 ampere and 0.50 kilohertz of operating frequency. Then we have the transistor group. The transistor BJT, power transistor BJT, can be rated as 1400 volt and 400 ampere of current, 10 kilohertz of operating frequency, whereas the power MOSFET can be operated at 100 kilohertz, and that's quite useful. Voltage rating is somewhat reduced of it is 1000 volt and 50 ampere of current. SIT and IGBT. IGBT we see 1200 volt and 500 ampere very commonly used and 50 kilohertz of operating frequency. So this is about the thyristor family device with their symbols. Sometimes questions are asked to draw the symbols of different devices, and here we get an idea of the voltage and the current rating, that is power handling capacity, as well as the operating frequency. Now coming to the first device here, LASCR, light activated SCR. So light construction wise, if we look, it is also 4 layer with 3 junctions and 3 terminal, anode, cathode and the gate taken from the P layer next to the cathode side, and it can be kept open. The gate can be kept open, or it could be a small gate current can be provided as in the SCR case. So the main component or material used is the silicon, and it is a semiconductor optoelectronic device, a switch with a lens arrangement. Here we see the lens arrangement for focusing the light, incident light, onto a small silicon pellet connected between the cathode and the gate. So when the light falls on this sensitive area, silicon pellet, then electrons are dispatched from its position and thus creating electrons and holes and generating electron hole pairs. Now this generated electron hole pairs is proportional to the intensity of light. More the light falling on the silicon pellet or the light sensitive area, more will be the electron hole pairs generated and the external current taken out through these terminals, anode, cathode. So it can be made more sensitive if we are uh, leaving the gate terminal open and inserting a resistor, a small resistor in between the gate and the cathode. If a small resistor is inserted, then sensitivity of the silicon pellet can be increased or LASCR can be increased. Now, what is the advantage? It is providing electrical isolation between the triggering source, the gate cathode circuit, to that of the switching device. So, this very particular electrical isolation is of much beneficial in many applications. Construction wise, we saw that it is very much similar to that of the SCR, 4-layered structure. Here is the construction diagram. Now, for the VI characteristics, the VI characteristics of LASCR is also similar to that of the SCR, silicon control rectifier, with the forward blocking mode, transition state and the forward conduction state, and down here we have the reverse blocking mode and very high current running when the reverse breakover voltage is reached. And by providing the gating current or increasing the light intensity, the breakover voltage can be reached earlier. What are the applications of the LASCR? It is used for high voltage, high current applications, then for compensating the static volt ampere power, then optical light controls, relays, phase control, motor control, and a large number of computer applications make use of LASCR. Then it can be used for a switching device, for power converters, then to trigger the high power SCRs, and so LASCR can be used. Now the power ratings of the LASCR. LASCR is generally low rated 3 ampere and a power rating of 100 milliwatt or 0.1 watt, or it could be as high as 6 kV, 6000 volt and 3500 ampere of current. So it can be manufactured, and on state voltage drop across the LASCR conducting LASCR is of the order 2 volt. Then light triggering requirement of the LASCR is of 5 milliampere. So that is about the light activated SCR. Now second device here is silicon controlled switch, SCS. So here again we see that it is 4-layered structure similar to that of the SCR, and there is 3 terminal similar to SCR plus 1 anode gate is taken out from the N layer near to the anode. So all the 4 layers are available for the external connection, and this anode gate is similar to that of the PUT, programmable unijunction transistor. So that is the additional modification, anode gate is taken. So there are 2 gates, anode gate and cathode gate. An equivalent circuit is similar to that of the SCR we see with the anode gate and cathode gate. In SCR we have only cathode gate, whereas in SCS we have here an anode gate added. So that is the modification, and it is also unilateral. The device current is designed to flow from anode to cathode, so it is unilateral for layer 3 junctions, PNP silicon device with 4 terminals, anode, cathode gate and cathode gate. Now SCS is a low power device compared to SCR. Okay. And the power handle is of the order small current is it is capable of handling 100 milliampere to 300 milliampere of anode current, and it is having a smaller size as compared to the SCR. A smaller leakage current and holding currents are also smaller as compared to SCR. Then SCS remains on until we remove the anode to cathode current or reverse the anode cathode polarities or apply a negative voltage to the anode gate. If we are applying a negative voltage to the anode gate, then it will turn off. Then if we are applying a negative voltage at the cathode gate, it is turned off, and if we are applying a positive anode gate voltage, then anode signal, then it will be turned off. And for turning on, we are applying positive gate voltage to the cathode or negative gate voltage to the anode for turning on. For turning off, positive gate voltage at the anode or negative gate voltage at the cathode gate. In this way, we can turn on and turn off the SCS. Now VR characteristics, again it is similar to that of the SCR, and we can achieve the breakover voltage at earlier stage if we are increasing the gating current. The on state voltage is increasing with the anode current and is not straight as we saw in the SCR. Now the applications of SCS, silicon controlled rectifier or silicon controlled switch. It is used in pulse generators, voltage sensors, counters, timing logic and triggering circuits make use of SCS. It can be used in lamp drivers, power switching circuits and logic circuits, as well as in essentially any circuit that requires switch that can be turned on and off by two separate control pulses. These are the references one can go through for further readings, more detailed readings, and websites, MSBT websites. We find the model solution answers, and there is another website. Thank you very much. That's all.